This problem is based on mathematical puzzle. In the diagram there are 9 boxes and these are labeled by the letters A to I. Each box has a distinct single digit natural numbers written on it, which means the numbers that can be filled in these boxes are 1 to 9. Two numbers on any two adjacent boxes are called as adjacent numbers, which means the numbers written on the boxes A and C would be considered as adjacent numbers. Same would be the case with A and D, and so on. Some additional info is also given here. Statement first is the sum of numbers on the boxes G and I is less than 13, which means G plus I is less than 13. The sum of numbers on the boxes adjacent to H is equal to the sum of the number of boxes adjacent to G. The boxes that are adjacent to both G as well as H are A and B, so while considering the sum we would not consider these two boxes. The remaining boxes are adjacent to H are G and I, adjacent to H are G are E and H. Therefore G plus I is equal to E plus H. In the next statement it is given that the sum of the numbers on the boxes that are adjacent to the box containing 5 is 30. Out of the given numbers, a sum of 30 can be obtained by taking at least 4 numbers. In case of 4 numbers we need to take numbers 9, 8, 7, 6. In case of 5 numbers we'll have more possibilities than 1, which means the box that contains 5 has at least 4 boxes adjacent to it, and from the figure it can be noted that the maximum number of boxes that can be adjacent to any box is 5, and it is possible for box A and B, and for the rest of the boxes number of boxes adjacent to it either is 5 or is 4 or less than this. In statement 4th it is given that the sum of the numbers on boxes C and D is less than 6. In statement 5th it is given that E does not have the lowest number and F does not have the highest number, which means E is not equal to 1 and F is not equal to 9. The sum of the numbers on the boxes G and H is prime. And in statement 7 it is given that the sum of the numbers on the boxes adjacent to D exceed the sum of the number of numbers on the boxes adjacent to F by 6. The boxes that are adjacent to both C as well as D are A and B, and the remaining box that is adjacent to C is E and that to D is F, which means F is E plus 6. The possible solution for E and F are for E1 F9, rather F7 when E is 2, F is 8, when E is 3, F is 9, but we know that E cannot be 1 and F cannot be 9, so the only possibility here is E equals 2 and F equals 8. Now move to the statement 3rd. If we consider that box A has 5, then the sum of the numbers in the boxes adjacent to A has to be 30. We know that G plus the boxes that are adjacent to A are C, D, G, I and H. Sum of C and D is less than 6. Sum of G and I is less than 13, and we know that number in any box cannot exceed 9, which means the sum of the numbers in the boxes adjacent to A cannot be 30. The same will be the case with box B, which means 5 cannot be placed in box B as well. Now moving to box G, because this also has at least 4 boxes adjacent to it. We know that the number in box E is 2, and there are exactly 4 boxes adjacent to G, which means the sum of the numbers in the boxes adjacent to G cannot be 30. And when we explore the same thing for H, we would realize it will not be 30, because the boxes that are adjacent to H are G and I, and their sum is less than 13, and the maximum sum of the numbers in boxes A and B can be 17. Therefore sum cannot be 30, at max it could be 29. So the only possibility for 5 is box I, which means 5 is written in box 5. Now coming to condition second, which states the sum of numbers in boxes G and I is equal to E and H, and we know that the number in box H has to be 1 out of 9, 7 and 6. When we take 9 for box H, then sum of E and H will be 11, and the sum of I and G has to be 11, and I is 5, which means G has to be 6, which is not possible because 6 has to go for either H or A or B, which means G cannot be 9. Similarly, on checking, we find that H cannot be 8 as well. The only value that H can take is 7. In that scenario, G will be 4. Now we are left with number 1, 3, 6, 9. As we know that 6 and 9 are the numbers that are to go in boxes that are adjacent to I. Therefore 6 and 9 will go in boxes A and B in any order, which means A can have 6 or 9, similarly B can have 9 or 6. Now 1, 3 can go in C and D in any order. So this is the final picture that we have. Now let's move to the question. In the first question, it is asking which of the following statement is sufficient to find the number written on box C. So we have to find the number written on box C. From our arrangement, it could be either 1 or 3. So let's explore the first statement, in which it is given that the sum of the numbers on boxes adjacent to F is more than the sum of the number on boxes adjacent to E. Sum of the numbers on boxes adjacent to F is 20 plus 3 or 1, as we do not know which number or which box rather number would be in box D. Similarly, the sum of the numbers in boxes adjacent to E is 19 plus 1 or 3. As we do not know what will be the number in box C, it can be 1 or 3, and here it is given that the sum of the numbers on boxes adjacent to F is more than that of adjacent to E, and this is possible only when D is 3 and C is 1, which means statement 1 is alone sufficient to determine the number written on the box C. Now come to the second statement. In this statement it is given that the sum of the numbers on boxes adjacent to F is less than the sum of the numbers on boxes adjacent to E. We can proceed in a similar manner and we'll get reverse result, that is, in that case D will be 1 and C will be 3. Therefore either of the statements alone is sufficient to answer the question, which is option 3. In the next question we have to find for how many boxes the number written on them can be uniquely determined. There are 4 boxes on which number written can be determined uniquely, and these boxes are E, F, G, H, I. Therefore option D is the correct answer. In the next question it is asking for how many pairs of adjacent boxes the sum of the numbers on them is 15. On checking the grid, we find that there is no pair of adjacent boxes such that the sum of numbers on them is 15. Hence answer of this question has to be option A. In the last question it is asking for how many boxes the sum of the numbers on the boxes adjacent to them must be a prime. On checking, we find that the required boxes are C, D and E. Here we don't need to do anything, just we need to add numbers or possible sums of numbers written on adjacent to given boxes, and on doing this we find that C, D and E are the 3 boxes that satisfy the given condition. Hence option B is the correct answer.